Hello and welcome everybody and Happy New Year. It is New Year's Day in half the world, I guess. And welcome to Launchpad Astronomy. I'm Christian Reddy, your friendly neighborhood astronomer. So wonderful to see all of you today. I can't believe how many of you are here today. Holy moly, I'm looking... 7,000 people are you all watching? Well, we are about to disappoint every one of you. No, I'm just kidding. I hope not. But, we're all here to talk about a Sunshield that's deploying in space today. I mean, how cool is that? And maybe wherever you are, you're having a nice day off, a nice relaxing day. Maybe you're at work, but you're able to get away just a little bit and check in. Or maybe you're not watching at all, in which case it's nice to see you from the future if you're watching this as a replay. So thank you very much. This is great to have you. I've already had some generous super chats from folks, and I'm having a hard time keeping up with all the stuff. But let me go ahead and just talk about what it is we're going to be doing today. And that is really we're just having a conversation about what is the most critical set of deployments. I mean, I think we can all agree this is certainly the highest risk part of the unfolding of James Webb. And yes, Durga Yadav asked if this is live. This is live. We are here. And I've been asked to switch to slow mode. Okay, can I do that while we're here? I don't know if I can or not. And if I cannot, I apologize. If I can figure out how to turn on slow mode in a moment, I will. But thank you all so much. We're going to be just having, like I said, a conversation again, just to clarify. And so, is it a conversation or an unfolding? Well, the thing of it is that Webb is presently initiating its unfolding. I think right about now. That's one of the reasons we're live right now. Just to say, so my mic is hot. Okay, let me go ahead and adjust it. Hopefully, that's a little bit better. If that's a little bit still too hot, kindly let me know. But the thing is that now we have a Sunshield that is presently unfolding in space. Now, one thing is that we don't get to actually see this. I want to be really 100 with you guys. We're not going to be able to see this actually happening because there aren't any cameras installed on Webb. And quite frankly, they would very much like to just get the telemetry. But I've got a guest on today who really knows a thing, or she knows everything about Webb, and she is a wonderful guest, and she's going to help us learn more about Webb and help us to understand just what this deployment is today and just how this is all literally unfolding in space. Please join me in welcoming my guest, Dr. Heidi Hammel. And that's not her. So I had it. You know what? This is what I get for trying to throw this thing together at the last minute. But and that's not her either. Okay, so you know what? I've already gotten into the mess ups here, so I want to go back to myself. And I don't know what happened to my shot with Heidi. I do apologize as I try to figure this thing out. By the way, if you all do me a favor, I want to know where you're checking in from. Could you go ahead and please put in the comments where you're watching from? And if you'd like to share this out on Twitter or Facebook or any of those other socials, it'll be great to have you. All right, so let me go ahead and do a little bit of work here to get my guest brought back in. I had her here just a moment ago, and then she disappeared, which really stank. And I wish it didn't happen, but it did, and that's okay, because we can fix that. I mean, the great thing about this is that we have the ability to fix things. And while I'm talking to you and acting so cool and nonchalant about it, all hell's breaking loose behind the scenes here, which is so much fun when everything just goes wrong. But that's all right, because we're going to get this going right now. So let me go ahead and do this. Let's go ahead and have a fix over here and a fix over here. Can I say, folks, gotta love live, when things go wrong, but that's all right. You know what? Things go wrong, but when you have such a swell bunch of folks watching, and they know just how terribly, woefully incompetent I am about this stuff, it's all good, right? So let's see. Okay, so I'm going to put Heidi's information there and try to clean this up a little bit. And then we're going to bring Heidi in. And Heidi's my witness. She knows that I actually had us both on camera when I was setting all this up. But you know what? That's okay, because we are scientists. No, that doesn't mean anything. It just means that, hey, we're dangerously unqualified is what it means. So let me go ahead and make a few more adjustments here. We're going to get everything just exactly perfect, as Bob Weir of the Grateful Dead used to say. But I'm going to go ahead and fix myself up here. So how's everyone doing today? You probably are thinking, wow, I did not expect to see this guy talk and try to troubleshoot things at the same time. But friends, that's what happens when you go live. Okay, everybody, I think I can now finally safely say that I've more or less gotten this thing sorted out. Oh yeah, and by the way, I've got something else to tell you guys. So please remind me to give you guys an announcement when I do bring Heidi on, or maybe Heidi can remind me of what my announcement is. But ladies and gentlemen, please welcome to the stage. Where is my... I don't believe it. I just had it and... Okay. And please welcome to the stage my guest, Dr. Heidi Hammel. Heidi, thanks so much for waiting and watching me screw up. And by the way, folks, I can see her like on a little monitor camera. She's behind the scenes laughing. She's like, "Ah, you suck." Heidi, good morning and thank you and Happy New Year.
Happy New Year's Eve. It's great to be here with you and with all your guests.
We're excited to have you as well. Let's see. So, Heidi, could you give me a mic check, please? I just want to make sure that we're hearing you loud and clear. Hello, Heidi. 1, 2, 3.
Hi, I'm Heidi Hammel. I'm an interdisciplinary scientist for James Webb Space Telescope.
So what does that mean exactly, to be an interdisciplinary scientist? I mean, I know that James Webb has a lot of different science programs loaded up already in the ground system, ready to go, but what does it mean to be an interdisciplinary scientist?
Years ago, decades ago, when we were starting this program, NASA put out a call for proposals asking the science community to propose what they would do with the James Webb Space Telescope once it launched. And this was in 2002. And so I wrote a proposal with dozens of my colleagues saying, when this telescope launches, I would like to use this telescope to do observations of objects in our solar system to complement the spacecraft that we do all across our solar system. And I propose to do many things.
Heidi, if I may interrupt you just for a moment, please. A few folks are saying they're having a difficult time hearing you. Can you make sure that your microphone volume is turned up?
Mm-hmm.
And
you can try to talk me through that.
Okay. Well, basically, it's just whatever audio inputs you're using on your computer. You just want to make sure that your microphone is turned up. Now,
they're all turned up. So I can try to speak louder and more slowly if that helps.
I hope it does. I hope both of us are now coming in, because according to this, I'm seeing my levels and your levels were basically the same. So I really do hope this is getting better. Let me just scroll through here, and yeah. Okay, good. So it is obvious. Obvious Schism says it is better. Good now. Thank you. Okay.
So let me just finish then quickly.
Please.
The science working group for the James Webb Space Telescope is composed of the people who lead the instruments and the project scientists, and then 6 interdisciplinary scientists, of which I'm one. And as I was saying, those were competitively selected back in 2003. And we can use all of the instruments for our science, and that's why we're interdisciplinary.
Okay.
We aren't restricted to one. I think that the announcement you wanted to make was to let people know that we are having a conversation here about James Webb Space Telescope and the deployments. We do not have a live feed of the deployments. We do not have a live feed of the Mission Operations Center at Space Telescope Science Institute. So if people are joining because they think they will see live deployments, I'm very sorry, but that is not going to happen. This is an opportunity to track in real time what is going
We will
on.
track it. We will track it indeed. As a matter of fact, so just to kind of cut to the chase, the latest update. Really, it's very simple. Webb is currently undergoing its mid-boom deployment. We're going to talk more about that in a moment. This is a very, very slow and careful procedure, just like with everything else. It's not like the booms pop out like we see in all those beautiful animations that NASA's provided for us. They are there to help us visualize what's going to happen, to literally see what's happening. But think of those as very much time-lapse, speed ups. No, instead what we're going to be doing today is kind of just chatting, and then as information gets released, if it does release during our show, we're going to tell you. We're going to bring it to you as soon as we know. So as soon as we know, we'll tell you. So we have, there's another announcement that we have as well. Should I go ahead and talk about that, Heidi? I think we probably should, because in case people are thinking that they've been totally flim-flammed on this, we actually have a little something in mind. It's the end of the year, and it's the holidays, and why not? We're gonna do some giveaways today. We are going to be giving away some JWST swag and some Launchpad Astronomy swag, and we're going to be doing that probably around like the bottom of the hour or something like that, and then maybe we'll do another one at the top of the next hour just to kind of have a little bit of fun. We'll ask you guys a question, you'll put in your answer, and the first person that can get it right will get something in the mail from me. So just as a thank you for watching today and hanging out, hopefully we'll have a little bit of fun today. So there will be a media briefing on January 7th. That is true. There's a media briefing on January 7th. That'll be after all of the major deployments have finished. And there will be a media briefing, I believe, on Sunday evening if everything goes well. And Car Galaxy, I like those gold JWST gold pins. Yep, there you go. We can get you one of these, or something even nicer. Maybe we'll see. So yeah, there'll be some swag. Why not? We'll just have a little fun today. We're already getting hit with some questions, but before I get to questions, let me just let Heidi just kind of finish a little bit about. Was there anything that you wanted to comment on or mention before we start talking about the status of the deployments and stuff like that?
Sure. Well, there's almost an infinite amount that I could say. Let me answer one question that I did see floating by. People said, is that the same Heidi Hammel from Shoemaker-Levy 9? The answer is yes. I was the one who did do that back in 1994, used the Hubble Space Telescope to watch the fragments of Shoemaker-Levy 9 crash into the planet Jupiter. That's me. And I did want to say, too, that everything is going well so far. I have a little checklist that I follow along, and I get updates as you do on Twitter. I also get some back channel updates on things. And so everything is going very, very well with JWST so far. And so I'm really happy about that. It's been a long road to get here for those of us who've been working on this project for decades. So it's really exciting.
That's so cool. That is a question that I have. I mean, you're not there in the Mission Operations Center, but you do have some back channel communication. Just what's the general mood and the general vibe like from your colleagues down at Space Telescope?
The mood is generally good. It's tense because this is a tense time. Right. And so, but people's spirits are up. They're good. They're making the best of it. What a tough situation for all of them. For those who follow me on Twitter know that I just did a shout out for my colleagues, especially the ones who are working tonight and the ones who had to work on Christmas Day. They're away from their families and their friends. They're doing the hard work. And I just want to make sure that we thank them publicly for the hard work that they do.
Absolutely. 100%. I agree. I know that nobody was looking forward to, to working on Christmas. I mean, it was sort of forced upon them just with the way everything literally aligned. But just giving them a shout out, I think, is really cool and absolutely well deserved. I mean, they are talk about the hardest working people in astrophysics right now. They really are, so yeah, wonderful stuff. Let me take a look at, see if I can share. I want to share with everybody. Let's see. Yeah, this is what I wanted to share. So I'm just going to bring up the Where is Web web page, WEB page, or Web BB page, whatever. You know what I mean. I'm bringing up the Where is Web. Let's go ahead and put.
Oh, your volume just disappeared, Christian, when you did that.
Yep, sorry about that. I am back now. Okay. So this is web.nasa.gov, and this is following the current state of the spacecraft. This is the telemetry that we're allowed to see. And by the way, what's telemetry? Heidi, what is telemetry? I don't know how these things work.
Telemetry is radio signals that we get back from the spacecraft. There are sensors on all different aspects of this spacecraft that are paying very close attention to every movement that goes on. And that information is radioed back to us and accepted through the Deep Space Network, and then sent to the Mission Operations Center, which we call the MOC, M-O-C, at Space Telescope Science Institute. And there it's displayed on screens, and people track that information. People are asking a lot, why don't we have cameras?
Where's the camera? Yeah, Heidi.
And all I can tell you is that some of us lobbied very hard for many years to get cameras on the telescope to watch these deployments. But cameras are mass, and cameras require power. And for many years, we were very mass constrained on this telescope. We could not put additional mass on for things that weren't specifically related to the operations of the telescope and for the science itself. And so cameras, those were one of those nice to have, would be cool to see, but not critical for operations. And that is why we don't have cameras on the spacecraft itself. I mean, science cameras, yes, to look out into the universe.
I was saying, we have cameras on Webb, the very important cameras indeed.
We don't have little GoPros watching deployments.
So there's no selfie stick attached to Webb to look back.
Stick.
Say hi.
I think all of you who are watching know the closest to that was on the rocket.
Yes.
Ariane put a camera to watch the telescope separate from the rocket. And that was the imagery that we saw of the telescope moving away from the rocket, and then our solar panels deploying and sparkling in the sun. That was a camera on Ariane, the rocket, not on the telescope. So we will not get pictures of these deployments. That's why following along online is the only way to do it. And I also saw a question float by saying, how can you people say this is live? I heard that it already happened. The time on the website was blah, blah, blah. Those times that are on the website here, and even the days as we get further out, those are nominal times. If everything is exactly, perfectly according to plan, this is when things happen. But this is rocket science. Things don't always go exactly according to plan. And so those times are, representational. And so that's why we're all checking our phones, watching the Twitter feeds. NASA will announce when we have the first half of this deployment. It's going to happen in two pieces. There's two different booms that need to move off from one side and then the other side. And so we have to get one boom deployed. And then once all the telemetry says everything is excellent, then we will do the other boom. And the videos you see, as Christian mentioned, are very speeded up. All right. And so these things don't just go, they're huge tennis court size things, and they move very slowly. So it could be a few hours before we hear that first boom is deployed. So if you are on here expecting to see it live, I'm just telling you, we're not likely to be we won't be able to show it to you. And we will announce it to you when we hear from NASA that it is done. So just truth in advertising.
Yeah, absolutely, Heidi. We want to be 100 with you guys, but hey, you know what though? We're still having some fun, and yes, I don't have my stuff up here. That's because what I'm trying to do right now is I've got my head down here, and I am attempting to change the chat to slow mode, and I believe I've just done it. So the chat is now in slow mode. If everything is correct, it should ease up, throttle back a little bit. Although we just love the fact that you guys are also enthusiastic. But hopefully this can make our conversation a little bit easier for us to keep track of. So what we're looking at right now is a replay of the launch from Christmas Day. Oh my goodness, what a beautiful and flawless launch that was. Oh, and John, thanks. I'm going to deploy a beer. Happy New Year. Happy New Year to you too. And thank you so much for the super chat, John. Thank you all for these super chats. Gosh, I'm having a hard time keeping up, and this is a wonderful problem to have. So we got a question here from Constellation Pegasus, and what I'm going to do, we have a super chat question. I'm just going to put that in my little folder of questions to return to. But thank you very much. It is a bit of a busy stream here, so, but this is a great problem to have. And if I sound like I'm babbling, well, I kind of am.
I'll answer some of the questions that go through.
But
here.
Let's go ahead. So here's a question: is there a delay for the telemetry?
The telemetry is not delayed. It goes directly through the Deep Space Net into the Mission Operations Center. By directly, I mean it's got to go through relay stations on the Earth.
Okay, right.
That sort of thing. But we there in the Mission Operations Center, they get that telemetry as soon as possible. NASA does not release that information out to the public generally. We wait until, the way they're handling James Webb Space Telescope is they're waiting until certain things are accomplished, and then they announce this is successfully done.
Okay, so they're trying to basically understand the telemetry, interpret it correctly, make sure they know what they're talking about before they say something, and then, right. Yeah, but when you say that this is, and again, I'm not trying to be all like, yay, everything's perfect over here, but, you know, folks, I know this may seem a little bit disappointing, like, oh, I want to see it live and all that kind of stuff. Guys, we're not Russia, we're not China. We are doing this in the open. We are letting people know exactly what's happening as soon as they find out what exactly happened. So that's important. I mean, this is as live as you can get, between telemetry download, interpretation, analysis, confirmation, and this is so critical. The last thing they'd ever want to do is put out a statement saying this happened, and then they realize, oh, no, that didn't happen yet, and they have to go back and correct, and it just gets just gets so confusing so quickly. So no, they're going to make sure that they know what it is that they're talking about, and man, when they do, they tell us, and that's how it goes.
Let's talk a little bit about the Sunshield deployment and why this is a really important and careful deployment. The Sunshield is a very large structure, but it is a very delicate structure. It's made of multiple layers of a very thin material called Kapton. And Kapton is a really good insulator. I should have brought this down. I should have had my visual ready. Imagine a potato chip bag and that thin, crinkly kind of metallic potato chip bag. That is kind of what Kapton is in terms of its thickness and strength. And so these giant sheets of Kapton have all been carefully folded up and put inside this rocket. And so what has already happened, I know those you who follow, we know that the two giant pallets that hold the folded up Sunshield, they have opened up already. And so the Sunshield is now kind of lying in a big flat stretch. What is happening, and the second thing that happened with that is the covers have rolled off of the pallets. Those things have already happened. What we're waiting to hear now is that the side booms that are going to open this thing up to the sides will start to move. And they have to do it very slowly and very carefully because, as I said, this Kapton material is very thin and it tears easily. How do we know that? Because we spent years testing it on the ground, doing deployments and moving things. And in some cases, the Kapton did tear. And so we had to go back and say, why did it tear? When I say we, I mean the engineers, not me personally. I'm a scientist.
Oh, okay. You're not an engineer, right? You didn't build this, right?
I didn't build this. I'm going to use it, but I've spent years working with it. So when things did tear, the engineering teams stopped, and said, this does not look good. Evaluate what happened. Where's the strain coming that caused the tear? How do we fix that? And then they would modify the design. This is really one reason it took this telescope so many years to get to this stage. People are like, why does it take so long for Webb? Why was it delayed so many times? It's like, we've never done this. We've never deployed huge piece of Kapton in space like this. And so it's been a very painstaking process. So although I am not in the Mission Operations Center right now, I can share with you how I'm imagining this is happening right now. They are getting telemetry. They are reading sensors. They are saying, do we have the right tension on the material? Is it correct that the covers have opened completely? If things aren't quite correct, then they're probably establishing what we would call an anomaly review board.
Right.
This happens anytime there's an anomaly or something kind of going wrong. The telemetry says, that actuator didn't deploy according to the telemetry. They establish an anomaly review board that takes all the data that they have for that particular piece of equipment and all the other equipment in the vicinity, and they analyze it and say, what do we know from this telemetry? What is our best estimate of what is happening on the spacecraft, and is it safe to proceed?
Right. Right, and that's a very critical thing. And by the way, I if I might interject here, many years ago, and we're going back well over 20 years ago, I actually did do spacecraft flight operations. So I did work as a spacecraft controller down at Goddard Space Flight Center, and I was steeped in all of this world of telemetry and how do you create a picture of something that you can't actually see just using nothing but data points. And everything Heidi has just said is spot on. Because all of the procedures that Heidi just described were procedures that we used on spacecraft, space science missions you probably never heard of, like the Fast Auroral Snapshot Explorer or the Transient Coronal Explorer, right? For the sun. This is like daily business, and forget trying to deploy something. That's just operating a spacecraft, especially when something is just a little bit different and you have to think it through, and it really does take time, Craig, I absolutely agree. Dr. Hammel is great. She's the best, and this is why I love all of my guests, but it's just great to have Heidi with us today. So can we see the telemetry for JWST? Right. Again, this is as close to telemetry as we can see. If you meant, can I scroll up here? I'm happy to do that. But there was actually a question that came through. Let's see. Well, I'm going to probably get these questions out of order, but it was a question about temperature that Dave asked. Are these temperatures accurate? They don't seem to change. Heidi, I think that they are accurate because they shouldn't change very much if the shield is not extended. I think once the shield goes out, once the shield is fully out, then we're going to see those temperatures plummet on the spacecraft side. Is that your understanding?
Yeah, that's my understanding as well. We really need these multiple layers to be deployed so that we can get the temperature protection from one side of the Sunshield to the other. So what you're seeing there is the temperatures on the pallet for before and after the pallets closed up. And so we are not getting the cooling yet that we expect to see once the Sunshields are deployed.
Mm-hmm. And On the Archipelago asked, is the Sunshield the toughest deployment? I think it is. I think this is the most complex phase of the entire deployment sequence. What's your understanding, Heidi?
Every deployment is a tough deployment until you're on the other side.
Well, that's true. Yeah, that's true. But I mean, at the same time,
it is.
Yeah.
We have practiced all of these deployments multiple times, but as those of you who work in the spacecraft business know, or those of you who followed it for years know, sometimes the deployments that fail are not the ones you expected. For example, on the Galileo spacecraft to Jupiter, it was the main antenna that didn't deploy. All right.
Yeah.
We've got so many antennae in space. Like, how could your main antenna not deploy? But that was the failure mode. So I'm really not being facetious when I say that
Yeah.
every deployment is crucial. People have talked about the hundreds of single point failures on this mission. That means if something fails, there isn't a backup for it. And there are hundreds of deployments that have to happen. Many have already happened, thank goodness, but there are hundreds more to go. And each one of them is crucial. I worry myself a lot about the secondary mirror, folding down, because although there currently is sunlight shining on our mirrors and going into the hole in the center of the mirror, into the cameras, we won't have focused sunlight unless we have a secondary mirror. And so, to me, that's a crucial deployment that has to happen. And they have to happen in certain steps. The way this spacecraft is constructed, things have to happen in a certain order. And so if something happens today, if the telemetry suggests to us that we're not ready to deploy one boom or the other boom, we will not continue on the sequence.
Right. You're not going to just barrel down the road and hope everything works.
Right. Exactly. We will stop. We will have an anomaly review board that will assess what is happening. And then we will keep working until we get that one done.
Right.
And then we will move on. So all the dates and times you see, they will shift forward because we need to get things done in certain orders.
Right. Because by that point, you are quite literally, and I realize I'm doing this live in front of everybody. My apologies for the lack of production here, but let me go ahead and kill that. Come back to this. What I was going to say is that there's always there's as you were saying, Heidi, there are always things that can crop up that can go wrong. And when we see the animations, which is what I was trying to bring up just now, but when we do see the animations, keep in mind these are the major ones, and these are the ones that they can show us through animation in the sense of, okay, here's what the spacecraft is doing. What we don't get to see, and and therefore don't think about, are all of the releases and the deployments and the triggers that are actually happening inside the spacecraft. All of these literally mechanical levers and switches to release this bit, to verify this is done, and then releasing that. So when one of those go wrong, no camera in the world can help you because you can't even put a camera inside the telescope to see.
Exactly. I'll give you some little background story for people. In the years of development, there's a piece of this spacecraft that when you're trying to release equipment, there's a little device called a non-explosive actuator, an NEA. It's like a little latch, kind of.
Okay.
Sorry, I'm kind of waving my hands because I don't really want to go into the details, but it's like a little latch. And at the appropriate time, you send a signal to it and the little latch goes pop, and then you can do your deployment. Well, in the early years, we had a lot of trouble with these non-explosive actuators.
Oh my gosh.
There's a couple hundred of them on there. And so, every time it's time for non-explosive actuators, they're all working. They've all been working great. I don't want to give you the wrong impression.
Right.
Talking about like 10 years ago when we were in the development stage.
Okay.
They're all working great now, but just, how it is, you get a little scarred when I hear NEA, I'm like, non-explosive actuator. Oh, it's, it's one of those things.
So nothing to worry about, right? I mean, it's all going to be fine. Yeah.
Well, this is rocket science. I've been saying this to people all along. Are you scared? Are you nervous? I'm like, yes, I am. I'm nervous.
Yeah.
Until we're at L2, fully deployed, fully calibrated, and our science instruments all checked out and taking data. Until that moment, I will continue to be nervous because we will not start getting our science until that point. And that is not going to be for months. I mean, here we are today, we're talking about the booms deploying for the Sunshield. But again, this is only one step on a very long, many month-long process. So it's going to be a long time that I'm going to be nervous. I was at a yoga class earlier today. Yoga, like deep breathing.
Okay, yeah.
We all have our ways that we try to cope with the stress. We'll continue to be nervous until we're taking data.
I'm showing now the animation that we've been talking about, so at the risk of repeating everything that we've just been saying, it is here, and I'll be able to scrub back and forth through this as necessary in order for us to see what's going on. But I thought what we could do at this point, Heidi, is just talk briefly, just kind of recap where we are and what we've seen so far. I mean, we had that spectacular launch the other day, well, about a week ago. Then we got to this part, which was probably my favorite part of the launch, which was the separation. I think that was absolutely inspiring and exciting to see. And yes, that was our only look at Webb. And I guess I could try to find that footage, but for right now, I'm just glad I got something working. So I'm going to go ahead and just let this run just for a moment. And then maybe later on I can bring up the deployment. Oh, but you know what, though? We've passed the bottom of the hour, and we forgot to do a giveaway. We forgot to do a giveaway. What do you think, folks? Should we try to do a giveaway? Okay, here's how this is going to work, friends. Let me go ahead and bring up Heidi and myself. I'm going to come back and talk about this deployment in a moment. But first of all, I want to come back and just talk to you guys just for a second. Okay, so we don't need that. And I'm going to go ahead. No, don't need that. Where's me and Heidi? For crying out loud. Who set this thing up? I did. I did. I set this up. This is the part where Heidi is just laughing at me, and
it's the talent. I got nothing to do with the mechanics.
You are the talent, and I am not. So what I want to do is I want to bring up just my two-shot of myself and my guest. Now, if I belong to a group of wonderful, talented live streamers, and we kind of help each other with our live streams. If any of them are watching, they are probably absolutely disgusted with me right now, but that's okay. It's what it is, right? So I'm going to go ahead and bring this back up, and here we are. So here's how I think we could do our giveaway. What I'll do is I'll bring up a web page with a product that I think we're going to go ahead and give away. And Heidi, while I'm doing that, why don't you think of a question that you can ask about Webb, and then everyone will type in their answers, and the first one that you see come through with the correct response gets the prize. So how does that sound?
Wow. Okay.
All right.
About Webb.
Yeah. Can you think of anything? And you don't have to, just kind of marinate on that. Just think about that for a sec, because what I'll do is I'm going to go up here to Science Socks. Because Science Socks, we actually have two vendors who have very, very generously agreed to, let us pilfer their stores for some swag. I mean, okay, I'm going to buy the swag, but you know what? They're being really cool about it. And let me go ahead and, there we go. We'll copy that, bring this up here, and we're going to bring up the James Webb Space Telescope. Now, you know what I think we should do? I think that because it is still the holiday season, I think it would be kind of fun to give away a beautiful, this really nice, let me see here, where is this it? All right, that's not the shot that I wanted. And that's not the shot I wanted either. Sorry, folks. Let me go ahead and get my screen back up here. It's weird. I just had it. I kind of threw this whole thing together at the last minute, and I clearly didn't think about it, but I'm going to show you what it is I want you guys to see, and I will show it to you, I promise. So Heidi, why don't you go ahead and just continue with what you were talking about with respect to with the remaining deployments while I set this up.
Okay, sure. Take your time.
Can you vamp? Yeah, I know. She's like, take your time. Hurry. There it is. I got it. I found it. Yep. All right. See that, folks? Who would like to have one of those hanging on your tree? See, Heidi's got one hanging right behind her. and I thought it would be fun to give one of these away. So, Heidi, do you have a question for the audience that you'd like to ask? Okay.
I do have a question, and here's my question. There's going to be a lot of science done with this telescope, including my own, which is solar system science. But this telescope was specifically designed for one key science observation. Does anyone know what that is? What is the key science that we designed this telescope to do?
What is the raison d'etre of Webb? Okay, so folks, think about it. Type in your response. The first response that Heidi sees that is correct, she'll...
Oh, it's going so fast.
She'll mention that person, and then...
Word infrared, but that's not the science.
Right, it will be looking in the infrared part of the spectrum.
Going so fast, it's hard for me to see.
This is the slow mode we have running on the chat, by the way.
So many people. I saw it go... hold on. Okay. Michelle Hollander's First Galaxies at the Birth of the Universe.
Okay. Michelle...
The first galaxies that formed after the Big Bang. We hope that we might be able to see the first stars, but that's going to be a little trickier because it's probably going to be impossible to directly image the first stars. However, we have a technique we use called gravitational lensing, and that is where we use clusters of galaxies that actually bend space-time like a magnifying glass and allow us to see things even further than that cluster of galaxies. And with this gravitational lensing, we might be able to see clusters that have the first stars in them.
Now, is this the person who is?
Yeah,
this
that's
okay,
the one. That's
great.
The one.
First galaxies at the birth of the universe. Yeah, I think nicely done. Well done, Michelle. Yay, excellent. And you know what else is really cool? Yeah, go ahead, Heidi.
I was just going to say, if any of you said that before this, I apologize. It's streaming past so fast. This is the first one I could capture with my eyes.
I should also point out, friends, that the way the chat works is that because this is all going through Google servers and there's like all these CDNs and other networks it has to go through, the order that the chats appear on your screen is seldom the order that appears in our screen. So it's what we see that we can only go by. So, Michelle, well done indeed, yay! So what do we like to do, Michelle? Michelle, if you would kindly send me an email, chris@christianready.com, or if you go to my YouTube channel page, you click on About, you'll see email, business email. Go ahead and send me a message with your mailing address, and I will order one of these and send it out to you, just as a thank you. Now, folks, let's do this on the honor system. Please don't email me, oh, hi, I'm the guy that got the... I got questions 24 through 52 correct. Let's be on the level with this, if you don't mind. But if you could do that, Michelle, that would be wonderful. Congratulations. And don't worry, friends, we're going to be giving away some more stuff throughout the day. I think we've got a lot of fun stuff here. We've got... Okay, so
that I thought might be interesting to answer.
Yeah, and okay.
With so many hinges and deployments and things on there, but we're in the cold of space. Is that a problem with all those deployments and hinges? That's a really excellent question, and the answer is for many of these we have little heaters on them to heat them up before it's time to deploy them, and so that takes that problem away. And even in some cases, we can actually slightly adjust the position of the spacecraft so that sunlight falls directly onto some of those hinges to help warm them up. So we take into account all of those factors as we're going through this deployment process. So thanks for that question.
That is a great question. And let me go ahead and bring up my my other screen here that I had. There we go. We were talking about this and just kind of recapping the... We were recapping the deployment. By the way, this at the risk of jumping around, what the heck? Let's jump around a little bit. This bit right here with the solar panel, I remember that showed up. We got to see that happen live, and I don't know if anybody remembers it or not. But while it was launching, as a matter of fact, maybe when Heidi starts talking about it, I'll cue up the actual video because there's a beautiful high definition video of it happening. But the solar panel deployed what we thought was early. Heidi, why was it early? Do you know?
I do know. Many of our deployments, and currently all of our deployments, are being done manually, being triggered by commands from the ground. But this one was actually not done manually. The deployment of that solar panel was done depending on the orbit itself, the orbital velocity and the position. And so the Ariane launch was so perfect, so excellent. It got us so close to the nominal trajectory that we wanted to be on that we didn't need that little solar panel sensor didn't need to wait for anything. It was already where it needed to be at the time it needed to be. And so it just automatically deployed. And that is why it came out a little earlier. We always have a contingency, we always leave a little margin for error, but there was no need for that margin of error because the launch was so precise. That's why it went a few minutes early.
That is so cool, Heidi. And forgive me as I attempt to find, as I'm talking to you, I'm trying to queue up the video of that actual launch. So yeah, that was a real on the money. Oh, actually, yeah, okay, never mind. So it's one of those things where I absolutely had it set up and I had it all queued up, and then, I lost it. This stuff's, what do you know? This stuff's kind of tricky to do. Let me go back to me and Heidi. No, that's NASA's. That is NASA's. What do you call it? Live feed right now, so they don't have anything. But anyway, this was a real fortuitous event just to see this happening while it was still on camera. So that was cool. We have Hippo character applauds while nodding in approval, saying good going. Thank you very much, Francis. Appreciate the super chat. Really do want to thank you for that. And I know that it looked a lot more interesting on the YouTube chat than it does right here, because our streaming software doesn't really show you the animation. It just describes it. So it's like a hippo character applauding, saying good going. That's fantastic.
You have any pictures of the Sunshield? Let's go back and talk about the Sunshield a little bit more, because that's kind of what
that's why we're here.
That's why we're here today. Today is what I call Boom Day. Today is the day of boom deployment.
Well, so let's see. So here we were with the. This is where we were, I believe, on Thursday. Or no, this was yesterday. Excuse me. Yeah, it was Thursday.
A couple days ago, where you see that the telescope assembly is moving away from the Sunshield. That was to allow space for the deployments to occur. And this, what you're seeing now, is it's effectively a trim tab. It's to help balance angular momentum on the telescope, so we need to use less fuel as we're doing our movements. And so in this configuration, the two pallets are fully open. And yesterday, those covers opened in this animation. You see the covers rolling back, revealing the silvery Sunshield itself, just the top layer of 5 layers. And so what we're waiting for today is confirmation that this the side booms start to move away, pulling this Sunshield material out. And that should be probably the next step in this animation.
Right, so there's the core covers. That actually has to happen just before. And now this is it, right? And this is what's happening. Well, frankly, this is what's happening now.
This is literally what is happening right now. That is the boom that is starting to move out. And it's going really fast here. We're doing it much, much more slowly, because you see that fabric. Well, it's not fabric. It's the Kapton layers, how they are floating around. We want to be very, very controlled as we pull this out, so that if anything starts to catch or snag, we stop, and wait, checking our sensors all the time until we get this thing fully deployed. Now, we just watched it happen, and you could stop it right there. If you can stop the video.
Yeah, because this is what we're seeing now is what's about to happen over the weekend. But let me spin it back here. So
that one side pulling out, it looks like it's happening in our time here in about 15 seconds. And in fact, it's going to probably take several hours for that to happen, because it's going to be done very, very slowly. And, each time it moves, every sensor is going to be checked. Is there unusual tension anywhere that might indicate a snag? When we were practicing this, when I say we, again, when the engineers at Northrop Grumman and the good engineers at Goddard Space Flight Center, when those teams were practicing these deployments, sometimes things did get caught. There are wires and pulleys, and sometimes the wire slipped off the pulley. And so it was like, whoa, we better fix that. And so, in space, we have to be very, very careful because we can't go back and fix it. We have to work with what we have right now. And that is why it's going to be taking a long time for us to hear about this. And it's only the first one. We're doing it first, the one side. And then once all of that is confirmed, then we will do the other side. So we may not even finish this all today. Just trying to be realistic and set expectations here. And for those of people who have the checklist that I've been using, if we find out that we are going to shift our timeline to the right, we'll publish a new checklist with updated dates so that we can be on track.
So I think the nominal schedule was that today, hopefully both booms can be deployed, but again, there is no guarantee of that whatsoever. It'll happen when they've decided that it is safe to happen. Full stop. But anyway, so they'll be taking their time doing that, and then what we're seeing now here in the animation, there we go. This is the tensioning of the Sunshield. This is bringing everything up and trying to keep the stuff taut. Now, one thing I wanted to ask you, Heidi, is that why do we need to keep this thing so tight? Like, why do we have to pull this stuff taut? Like, why not just raise it up and be done with it?
Well, we want to have these layers to be tight because we need them to be separated from one another. All right. Mm-hmm. These layers provide levels of insulation from the sun hitting one side to the telescope on the opposite side. And if these were loose and could touch one another, then we lose that insulating factor of space. It's this space, literally the space and then outer space between the layers that provides us the insulation that we need. And those of you who live in colder climates, I'm sure you heard your mother say, put on layers in the wintertime. Put on your layers. You have to have multiple layers. It keeps you warm. Well, the same is true here. It's the multiple layers that are keeping us cold. And how cold are they? NASA has some good graphics about this, but on the sunlit side, the warm side, the temperatures are going to be about 185 degrees Fahrenheit. That's pretty warm. 85 Celsius for those of you across the pond and in other countries. But on the cold side, these 5 layers are going to keep that temperature drop on the cold side, it'll be close to minus 388 degrees Fahrenheit or minus 233 Celsius. So in other words, we're talking about almost 500, 600 degrees temperature difference across those 5 layers of Kapton. And just for people to sort of visualize this, in this graphic, it's kind of a little wrong because it sort of shows the telescope like this, and you can sort of see the sun and the earth.
Yeah.
In reality, when we have the sun and the earth here, it's always going to be kind of perpendicular to the plane of the sky. We're always going to have that sun shield between the telescope and the sun, earth, and the moon. That's the alignment. That's always going to be that way. So that means that we will always be looking away from the sun, because we're looking into outer space, not at the sun. And that means that the piece of sky that we're going to look at is going to change over the year. In one part of the year we'll look in this half of the sky, the other part of the year we'll look in that half of the sky by design. And for those of you who care about the solar system, I'm a solar system scientist.
I was going to say, if you have a solar system question, especially of the outer planets, we have the queen of the outer planets right here with us.
We cannot look back with Webb to, there's a cone of avoidance or a range of avoidance that we can't look back. So we can never look back towards the moon or Earth or Venus or Mercury. And even the near Earth asteroids, We have certain tricks in our planned so that we can get certain near-Earth asteroids when they're at certain positions in the solar system where we don't have to look all the way back. But we will never be looking at the moon or Venus or Mercury with this telescope. It's just not ever going to happen because of our Sunshield.
Andy James, I just want to say thanks to Andy James. Could put Christian as head of JWST deployment. Look, man, I can't even get my shots to line up and fire on cue. You want me to deploy this telescope? No. I mean, thanks, man, but no way.
Well, question that I've seen flow through the chat like 4 times now, so I think maybe we ought to address it. It has to do with Sunshields and how big they are. They're big, giant tennis court size. I don't know if it's a lawn or a clay court. I don't know, but it's big. It's really big. And we're going to set this thing out at L2. Like, what happens if asteroids or micrometeorites hit that thing?
Yeah, I was trying to bring up that. Trying to bring up a question about that.
Worry about that. We worry about that. But we've done a lot of. First of all, we've already had quite a few spacecraft out at L2. All right, telescopes. And so by the telemetry from those telescopes, we have a pretty clear understanding of impact rates. You know, we can watch when things jiggle. If they get hit, you can see it move. So we have an idea of what the environment out at L2 is already like. So we have sort of a baseline of what the expectation is. And if these layers get tiny pinpricks in them, that's okay, you know. Obviously, if we get a supergiant asteroid that comes through and rips into shreds, all right, that's a problem. But we don't think that's going to happen. Space is big. And so we're more thinking about the micrometeorite impacts. And we can take quite a few hits across this imagine a tennis court, right? And then a micrometeorite impact on a tennis court, all right?
Yeah.
That's not going to change the overall cooling capability of each layer. And remember, there are 5 layers too. And so a micrometeorite, you know, it's going to have, they are sometimes hypervelocity, super high velocity. Technically, it's called hypervelocity.
Right.
They might make little holes. They might even make a couple of holes, but you know, they're probably going to be coming in at some random angle, right? Which we model, coming in at a random angle. And so from one layer to the next layer, the heat is not going to go through the hole. The heat, because if they're coming in at a random angle, the holes will not be aligned from this hypervelocity impact. So the long and the short of it is that we've thought a lot about this, people. Of course, we've thought about it. We've modeled it, and we've done risk assessment. And we don't think that that's going to be one of our key problems.
One thing I have here, Heidi, and I wanted to have this frame of the animation up here. This is obviously a not to scale depiction of Webb orbiting the Sun-Earth L2 point. The way the gravitational potential works at this location in space, think of it as almost like a saddle. All right, like if you're coming at it kind of like perpendicular. If you're kind of coming out like at a right angle, let me see if I can gesture with this. Hopefully you guys can see if you're kind of coming at it from like a right angle or tangent to the direction of motion, you're going to kind of fall into it. But in these directions, you're going to fall out of it. So it's a lot like being on, like trying to rest a marble on top of a saddle. Okay, think of it that way. So what you have, and I know in my video I said resting a marble on top of a bowl, but really it's more like a saddle. Anyway, the point I'm trying to make here is that you're going to see dust particles falling into this region from the sides, but then as soon as they fall in, they're going to fall out, going toward the sun and away from the sun. So that cuts down on the amount of junk that's collected at L2, and indeed it also cuts down the amount of junk that's collected at L1 and all the way over here at L3 if you look on the opposite side of the sun. Now, where you really do see a lot of garbage accumulating is going to be here at points L4 and L5, because now you're in kind of the gravitational equivalent of kind of like a valley, you might say. Now things just kind of fall in and just sort of stay there, they fly around. So does this mean that Webb will never be struck? No, as Heidi just said, it will be struck. This has been modeled and it's actually been factored into the design. They can take so many hits and so forth. But Heidi, we have these huge mirrors, these huge. I know we're talking about the Sunshield today, but what happens when those mirrors get whacked? let's go ahead and take a look at our telescope here. What's going to happen when these guys take a hit? Is that game over for the mission?
No, it's not game over. I mean,
Oh,
obviously,
okay,
like I
good.
said, if you have a super giant asteroid that destroys the telescope, okay,
Yeah.
game over, right?
Well, if that
It's
happens,
not likely to happen,
yeah, but if
right?
that happens, don't look up, and you'll be fine.
So the question really more is about dust and
Hmm.
micrometeorite impacts, because there's a lot of dust out there in the solar
Yeah.
system. But honestly, are all of our large ground-based telescopes, they also get dust on the mirrors. And what happens is, with dust and with micrometeorite impacts that cause little tiny uh, damages in small localized areas, what happens is that you don't lose the overall reflectivity of your telescope, right? This thing is 6.5 meters across. That's 21 feet across. That's a lot of area. And so if you lose a tiny bit of it to dust or a micrometeorite impact, you do lose efficiency of the telescope, but you don't lose the telescope. That isn't what happens. That's why our ground-based telescopes, we periodically clean them. Even the ones that have big tubes enclosing them, they still get dust. There's dust in the air. These things are open to the air. And so we periodically clean them. This telescope and our other space telescopes, we don't clean the telescopes, but we track the reflectivity of them by looking at standard stars over time. And we watch and see how that efficiency changes over time. And so maybe by the end of our 10-year mission, maybe we will start to lose, we'll go from 100% reflectivity down to 97% reflectivity, and so it will not be, we'll have to integrate longer to get to the same signal level than we would otherwise, but it's not the end of the mission. And I also want to mention too, for those who don't know, that this is a segmented mirror. And the segments are movable. They have actuators behind them, not the explosive ones I was talking about.
Yeah, please don't blow up the mirrors.
They're like little tiny, an analogy might be like little screws that can sort of screw in and screw out. And I'm waving my hand back and forth, but the distances that they're moving are the distances of human hairs. All right, that's like over time. And so we can actually change the shapes of these mirrors over time. And that is, in fact, what we will be doing for many, many months after we get to L2. We will be spending months slowly moving these mirrors to create a perfectly aligned surface of that whole giant 6.5 meter composite telescope.
Well, Heidi, I do want to talk a little bit about the mirrors. I know it sounds like we're getting way ahead of ourselves because we're just assuming everything's going to go great with the Sunshield. We do have a few more Sunshield questions to get to that we are going to talk about. But I also think that now it's at the top of the hour. I think it's time. Yeah, I think it's time for another giveaway, right? Heidi, I have a question I can think of, but do you have a question you'd like to go ahead?
You can do a question this time.
All right. And, well, we'll see. Why are Webb's bottom two Sunshield layers, why are they kind of pink purplish in color? What are they coated with that's giving them that pink purple color? Go ahead and put in your best answer as to what you think causes it. What's the deal with all of that pinky stuff going on here, that purple pink stuff? And I'm going to try to see if I can find the first response here. Okay, goodness gracious, this is the slow chat, and yet it's flying through here. So I'm going to continue to kind of... Aha, okay. I think I got it. I got the first one. Okay, it's up here. Let's see. As soon as I can find it, I will. Okay, well, you really couldn't... Oh. Okay, so I gotta get this. I gotta find this first person because it's like I'm scrolling up to find the first person to respond. But if you responded silicon, you are correct, And the first person that I see that that said silicon, and again, this is just what I saw, right? It was Cactus Heart 96 silicon layer. Yep, actually, it's a layer of both. It's Kapton, aluminum, and silicon, and it's that silicon that is giving the pink appearance to the bottom of Webb's Sunshield. So bringing that up to here, yeah, that's where we're getting. That's what that is. That's silicon-coated sunshield. I apologize. That's a bit of a mess, right? So, well done, Cactus Heart 96. If you would kindly reach out to me through the email address, if you go to my About page on my channel, go to Launchpad Astronomy on YouTube, go to About, and you'll see a business email inquiry. Kindly send me your name and mailing address, and you will be getting a one of these beautiful no, that's not it. That's, well, you're going to get some beautiful telemetry. No? Okay, I'll give you one of these instead. How's that sound? Yeah. So, something for your tree while you're still having it up for the holidays. Great. Okay, we're going to be doing more giveaways pretty soon, but I thought that would be kind of fun to do. You know, Heidi, I did have another question for you about the, well, actually, there were several questions, just a lot of questions about the Sunshield, but I think we had, let's see, we were talking about the Sunshield, we were talking about keeping it free of debris, but there's actually, well, JK, forgive me if we've already answered your question. I know that there are some people coming in as well as going out, so I don't mind reviewing a couple of questions for the benefit of those just joining us. But, you know, how does Kapton, like what's so special about Kapton as far as being able to withstand the temperatures and being pulled taut in the vacuum of space? Heidi, can you speak to that?
Sure. So I'm not a thermal engineer, so I'm going to give you my best.
Damn it, Jim! I'm an astrophysicist, not a yeah.
Jim, I'm an astrophysicist, not a doctor. So Kapton is a very good reflector of infrared light. Infrared light is the heat, is what we're really concerned about here. We're not really concerned about the visible light from the sun. It's the warmth from the sun. And so this material, Kapton, is particularly good at reflecting these infrared wavelengths of light, but it's not 100% doing that, all right? Some of the warmth will get through that layer. So then you have the next layer of Kapton. And that warmth has to get through interstellar space between them, like not just a physical separation, but it's space, the cold of space. Mm-hmm. And so some warmth will get through that layer as well. And so then you have the third layer. And the reason there's 5 layers is because when you do the math, knowing the distance from the sun, knowing how much solar thermal radiation is falling on that outer sun shield, and knowing how much it is reduced with each layer, then by the time you get to the 5th layer, you have reduced that thermal loading enough that you have enough cold for us to operate our telescope and our instruments effectively.
Right.
So I hope that answers it. If you want to get deep into the material science of why Kapton does this, I'm going to have to refer you to a NASA website where I'm sure that is discussed in detail.
Or is it made of unobtainium? Yeah, could be. We'll see. But no, it's Kapton. And Kapton is not like an atomic element or like that. That's actually the brand name of the material made by DuPont. It's a polyamide film. And I only know that because I read their website. I mean, you know.
Google is your friend for many of these questions.
Yeah, except for the sites that tell you it's an alien technology and things like that. Yeah, so...
Another question people are asking a lot. I tweeted earlier today that when these sun shields are deployed, there will be more sunlight reflected off of this telescope. So it will be brighter at that point and therefore easier to see from the ground. And immediately people are asking me, well, where is it going to be? Where can I see it? I'm like, I can't, I'm like, you know what? We have a website at the Jet Propulsion Laboratory, JPL, and the website is the Horizons website. And the JPL Horizons website is the site to go to for information about where to find things in our solar system. It has what we call the ephemerides, the positions, the locations, distances, and they are tracking James Webb Space Telescope at JPL Horizons right now. And so if you're an amateur astronomer and you want to track JWST, people have been able to do this. I've seen many beautiful images flying by on Twitter where people actually can track it. You can go to the JPL Horizons website and pull up the coordinates and then, figure out for yourself where that is in the sky and where to point your telescope. The other day, it was going through Orion's belt. That was the part of the sky that it was in. I actually honestly don't remember right now where it is. Maybe some of our amateur astronomers who are tracking it could post in the tweets.
This person did. Look at this. There it goes. Actually, this person actually did get caught Webb flying through, and I believe that is part of Orion. I believe that's part of.
It looks like even with our largest telescopes, it's so far away. It's a point source. We are not, even with Hubble, even with the Keck 10-meter telescopes, which is one of the largest in the world. We're not able to resolve Webb. We're not going to be able to see the deployments. We can't see the kite-shaped Sunshield. What we see is an increase in brightness that tells us that there's more sunlight reflecting off a larger surface area. And that's one way you'll know that this deployment has been effective. You'll be able to see an increase in the brightness.
It'll just get bright. Do you think Hubble would be able to resolve a diamond? I don't know. I should think it probably could. I mean, I'm sure it'll be larger than...
I don't know.
I don't know. Actually, I'd have to calculate it. I really don't know.
I'm not sure we would learn anything from that. So,
no. But,
Such a precious resource for us right now.
Exactly.
There's so much science we want to do that I would not recommend turning Hubble or Keck or Gemini or any of our large ground-based facilities to Webb. It's just not... I don't think we would gain anything from that.
I agree.
Many telescopes are seeing it. Most of them are amateurs, or people who have moderately good telescopes and they're good at tracking moving objects. There've been plenty of images, but it's a point source, so there's no science, there's no engineering to do that.
I mean, I would think that the benefit to look. I mean, basically, if there was an engineering need for it, like if something, heaven forbid, went wrong, and telemetry was not giving them a picture, and they were convinced that the answer would be somewhere on the sun-facing side of the shield, then maybe that's when they would say, let's request some emergency time on a large observatory, or even on Hubble.
I'm skeptical that you would learn anything from that.
I'm skeptical of that too. That's what I'm saying.
People are like, well, but I've seen pictures of Hubble and I've seen pictures of the International Space Station. People, those are like 300 miles away, 400 miles away, right? Where's Webb right now? You can go to the Where's website. I was actually trying to bring it up. I don't have it.
All right, I'll bring that up here for you. I'll switch over.
Last I checked was over 71,000 miles away.
734,000 kilometers.
100.
All right, we can do this in American units. We have 456,000 miles, or for the rest of the cool kids, it is 734,000 kilometers. It's far.
Again, Hubble and the space station are like 400 miles away.
They're right
this
here.
Is 400,000 miles away. All right, so we're not in the same ballpark at all. We won't be able to resolve it and see the structures and stuff like that. It's just not happening.
Bummer. But you know what, folks? We don't need to see it. We need to see what it will show us. We don't need to show the telescope. It needs to show us. So, okay, so what Grateful Dead song best symbolizes the JWST? Heidi, I know this is something that you've given a considerable amount of thought to. Have you concluded that analysis?
Wow, that's a tough one. I actually hadn't really gone through that in my head.
Oh, okay. Well,
certainly, what a long, strange trip it's been.
It really has been, yeah. But I'm going to go ahead with Dark Star because it's going to be able to.
Dark Star crashes, and I don't want this.
And then it explodes its light into ashes, right?
Exactly.
And so, but I mean, and that's the thing. Think about the way stars are forming, right? They're forming inside of these dark cocoons, and we know that they're in there, but we can't see them because of all that dust that's in the way. And to be able to penetrate the darkness and reveal the star, dark star crashes. So thank
Yeah,
you
I like
very
Eyes
much.
of the World. Eyes of the World is good. Tim Fry, thank you for that.
Okay, well
That's
done.
beautiful. This will be an eye for the world. The whole world is going to use this telescope. When NASA and ESA and the Canadian Space Agency built this, it's open to everyone, and we
Yeah.
got thousands of people applying to use it. So, hundreds of people from around the world. My team alone has dozens of people. That's great. I also think of playing in the band. You know,
Ooh, that's
because
good.
you got to have a band of people to make this work. I just like
It really is a band. It's an international band. It's
this.
all of humanity coming together. And honestly, I know it sounds cheesy and stuff like that, but I really do think this is humanity at its best. You know, it's nice to not be at each other's throats all the time. I know some people seem to enjoy that, but I think it's awesome that we can all come together internationally and work on this together. So, I mean, we have people from all around the world just hanging out, chatting together today. How cool
All
is
right,
this?
so
Right?
let's come back to some science because I've
Yay!
seen a few science questions go by.
All
One of
right.
the questions that is pertaining to my field was about whether or not James Webb Space Telescope will be able to find a new target for the New Horizons spacecraft, which, remember, flew by Pluto, then flew by another Kuiper Belt object called Arrokoth, and is continuing outward. And the answer to that is probably not. James Webb Space Telescope is designed to be what we call a pencil beam, like a
Yeah.
very small field of view. And so it's not well designed to be searching for new objects. Hubble was used to find Arrokoth, but it took hundred Hubble orbits to map
Right.
out the position of sky. I know that the New Horizons team has actually been using some ground-based telescopes, which do have a wide field of view, like the Subaru telescope, which has an instrument called Hypers Prime Cam, and they've been looking with that to find the next target for the New Horizons mission. A similar question to that is, will Webb be used to find Planet 9? This planet that's out there beyond the
Yeah.
Kuiper Belt.
It's not Planet. Nibiru's not Planet 9, but yeah, whatever. Right. You know.
Yeah, I mean, it's the same answer I have for you, that this is not a telescope that is really designed to find things.
Right.
However, if using our ground-based wide field instruments and equipment, we do find evidence for a Planet 9. If Mike Brown and his team find a candidate object, we will be able to look at that object and help characterize it to determine what it is, whether it is a large Kuiper Belt object or some other object like that. So we're really more of a characterizing telescope, not a finding telescope. And my last thing before I go back to you, Christian, is I get the same question about and someone says, isn't the Vera Rubin telescope
absolutely
absolutely, that's going to be a wide field, whole southern sky every 3 days.
And that's when
Grace Roman telescope, when we launch that in several years, is also like a wide field Hubble. It will be a better telescope for finding things. The other question we get asked is, are we going to find new exoplanets with this telescope? And it's the same answer. It's the same thing. This is not going to be a finding telescope, but characterizing exoplanets, absolutely. Planets that the TESS spacecraft, the Kepler spacecraft, our TRAPPIST telescopes on the ground, other things, we will be able to do very good characterization of known exoplanets. The last I recall, there's at least 68 known exoplanets that are going to be targeted by James Webb Space Telescope during the first year. And so there will be a lot of great new exoplanet science coming from James Webb Space Telescope. But it won't be finding them. It will be characterizing.
It'll be characterizing them and finding it. And I understand one of them is going to be the TRAPPIST system, correct? You want to...
Right, yeah.
All right, cool.
The TRAPPIST-1 system is a lovely system that has 8 Earth-sized planets all strung out there. Not like our solar system where we have 4 sort of Earth-sized and then 4 supergiant ones. This has 8 Earth-sized, and 3 of them are close to what we would call the habitable zone. In other words, at their distance from their star, water could potentially be liquid on its surface. And water is key for life as we know it, and therefore that's why we call that the habitable zone. So those planets, all of the TRAPPIST planets, and particularly the ones in the habitable zone, will be targeted by the James Webb Space Telescope for in-depth study during the first year.
Emil had a question: is infrared more reliable? I mean, Webb is an infrared telescope, so would that be more reliable or better suited to finding Earth-like planets? So what do you think, Heidi?
Okay, so first of all, remember we use that word find. We're not going to be looking to find planets.
Right.
We're going to be looking to characterize them. And we can do different kinds of characterization with infrared light than we can with visible light, say with Hubble. Hubble is doing visible wavelength and near infrared characterization of exoplanets already. We didn't design Webb to do exoplanet characterization. Remember our first giveaway, we designed Webb to find the first galaxies in the universe. And because of our universe's accelerating expansion, the light from the first galaxies is expanded in wavelength, which means it's in the red primarily. And so that is why we are designing this for infrared. That's why Webb is designed for infrared observations. It's to find those first galaxies. But molecules in atmospheres, like atmospheres in our solar system and atmospheres around other planets, they have a lot of very interesting transitions and emit and absorb light in the infrared. So the infrared capability of Webb will be just fabulous for atmospheric characterization of exoplanets and also planets in our solar system, which is my science. Is going to be doing with James Webb Space Telescope, among other things.
Well, Heidi, I know that you're more of an outer ice giant person, but Andrew G said Planet 9 is Pluto. I choose to die on this hill. So I guess Webb would be a great follow-up to the New Horizons, right? I guess that would be the best imagery the best science on Pluto since New Horizons flew past. Yes, and thank you for the super chat, Andrew. Appreciate it, man.
Yeah, not so much imagery, because
spectroscopies.
Far away, but spectroscopy, measuring the chemical constituents of the surface and the atmosphere, absolutely. All of Webb has the sensitivity to be able to detect and get spectra of all known Kuiper Belt objects. Think about that.
Right.
We can't look at all of the known Kuiper Belt objects because we aren't the only people that are using the telescope. Those pesky extragalactic astronomers and stellar astronomers, they want to use that telescope too. But we are planning to look at dozens of Kuiper Belt objects, including Pluto, Charon, Sedna, Eris, Makemake, Haumea, Orcus, Varuna, basically any Kuiper Belt object that has a name, we're probably going to be looking at it, and many that are still just alphanumeric designations as well. There's a team by Nimi Pinella Alonso. She and her team have who's called Disco TNOs, discovery and characterization of TNOs, and they're going to be looking at dozens of Kuiper Belt objects with James Webb Space Telescope. So I'm really excited to see what they come up with. And my team, we are combining with the other science teams, those of us who have guaranteed time. We have a combined program to look at many of the most popular and well-known Kuiper Belt objects. So stay tuned for that.
So now, at the risk of jumping around a little bit more, any word on where we are in the deployment sequence? Well, yeah, just to kind of bring us back to where we are, just to,
We're Googling.
We are Googling, but I'll go ahead and just return us back to this page right here. This is the latest telemetry that is being made publicly available, and we talked about this before. It's all an exercise, and this is all happening very, very slowly in space. So,
for those who joined late, we don't have direct lines to NASA, so we are learning as you are. What is happening there.
We're sharing this together.
As of this moment, we have not heard yet confirmation from NASA that that first boom has finished deploying yet. And remember what I said earlier, it takes hours to do this. So in this like one and a half, maybe if we push it out to 2 hours, we may not get confirmation on this yet. So sorry about that. If you had hoped to hear it live, we would,
we would
do
yeah, if we could bring it to you live, we would. I mean, this is like, no, but this is basically what's going on, and we've already talked about this before, but, this is a very highly sped up version of what's really happening. And I want to also be clear about something else, too. You notice that it deploys it in a very specific order. So the first thing that had to happen is these core covers had to be removed or had to be popped open. And then we're going to have what's called the plus J2. So this is the J axis going horizontally across, and this is the plus J2 deployment boom. So this is taking place, and as you could see, the shield extends, and what's pulling this is that there's actually some cables right here. So it's pulling this out, and this is happening very, very, very slowly. Literally so that, and by the way, we didn't really talk about this, Heidi, but there are sensors all over this thing that are looking for sudden accelerations or sudden stops in motion, which could indicate that there's a snag, that something isn't opening up the way they expected it to. And Heidi, correct me if I'm wrong. My understanding, and I may be wrong about this, my understanding is when one of those sensors fire, everything stops, and they assess what's going on. Was that a real, legit firing of that, let's call it a snag sensor, or was that an anomaly in the telemetry data? Okay, and then just start working the problem and troubleshooting. Is that how it? I mean, I'm heavily borrowing on my educated guesses of experience from my own spacecraft flying days, but what's your understanding?
So the process you're describing is the kind of process that takes place. And let me be clear, we're not talking about what's happening with this deployment right now. We're talking hypothetically about what happens when we measure something on the spacecraft, and it doesn't seem, the information we get back indicates it didn't happen exactly as we had planned. Things like this did happen, in the early days, that we were already long past, where there would be a sensor and the sensor reading saying, oh, this temperature isn't right, and I'm going to stop until you guys tell me to keep going. And then they would convene a team, an anomaly review board that would assess all the data and say, oh yeah, okay, now we understand there was this, that, the other. I'm waving my hands because I'm not going into details here, but it's okay. That was an okay thing. Even though it says it had a problem, we understand what the problem was, and here's a workaround, so now let's keep going. That's the kind of process that would take place if they encountered something happening with this. And the fact that we haven't heard anything does not mean that there's a problem. It just means that they have not yet fully completed this deployment. NASA's not giving us sort of live blow-by-blows of what is happening because, at some level, people overinterpret what they hear. If they hear, oh, sensor 5 is giving us a funny thing, they're like, oh, something's wrong, but it isn't. It just hasn't, they just haven't checked it out yet. And so to avoid all of that misinterpretation, they're just waiting sort of step by step, like, we'll tell you when it's done. Just trust us. We know what we're doing. So far, knock on wood, it's all been going very well.
I think we are in very much a no news is good news scenario. Obviously, if there is a significant anomaly or anything like that, NASA knows that people are waiting. They're going to issue a statement. They're going to keep us in the loop as to what's going on. As a matter of fact, while we're chatting about this, I should also draw your attention to another webpage that Heidi and I both look at frequently, and it is the let me bring up here blogs.nasa.gov/web. We'll bring this up here. Okay. So this was, that's right. This was from yesterday. But this is a blog that they're doing a pretty good job of keeping up to date. I know I said that, and the last entry was yesterday, but it's showing how the Sunshield covers were released. Again, once they know the situation on board the spacecraft, they're pretty good about getting something out there in the public. Plus, you can also follow them on Twitter, and they're doing a really good job, I think, of just keeping us in the loop. So we're just trying to provide you with a little bit of extra information that, they can only put out so much, and we have Heidi here to share with us some of the behind-the-scenes stuff, and I had a little bit of experience flying spacecraft back in the late 90s and early 2000s. So I think the other, so how long will it take to release information about what it finds to the public? Well, okay, you know what, we were I read that as a how long till they release information about the deployment. But as far as when they release information to the public, all the data becomes public after a while, and there's a couple of different scenarios in which the data becomes public, but eventually 100% of the data becomes public. Is that right, Heidi?
Yeah, eventually all the data becomes public. Science data. We're talking about science data here.
Right.
We're not releasing telemetry data. That just is not something that we release to the public. It's just used internally to understand the spacecraft. And we're not releasing other kinds of information about the telescope itself. It's, information about, you're seeing some temperatures, things like that. But in terms of science data, once we start doing the science, and that is not until later in the summer, like June, July, August, that is when we will start doing science with the James Webb Space Telescope. And there are different kinds of science that have different levels of protection, if you will. The general first of all, there's going to be what we call early release observations. All right, these are some images that the team at the Space Telescope Science Institute has already planned for Webb to demonstrate its capabilities, to demonstrate that it's working. And so they'll be the first images that are released. And that will be, like I said, late summer is when we will see those first early release observations. I don't know what they are. I was not part of the team that selected them, so I cannot tell you what they will be. My best guesses, and these are purely guesses based on my years of experience with Hubble, is that there's probably going to be a beautiful galaxy picture. There probably will be some kind of a lovely nebula picture, maybe a gorgeous globular cluster of stars, something like that. Something that really illustrates the beautiful imaging capability of the telescope. There are also programs that are called early release science programs. These are programs that the science community proposed to do for the benefit of the broad astrophysics community. And there are 13 of these programs. And these programs, as soon as that data is taken, will be made public to all of the astrophysical community immediately. Zero proprietary time. So as soon as that data is taken, the astrophysics community and the planetary science community gets that data. And there's a huge variety of programs. There's, like I said, 13 of them. There's some of them are exoplanets, some are deep galaxies, some are local galaxies to look at star structure. There's one in the solar system led by my colleague Imke de Pater and Thierry Fouché that is looking at Jupiter. And so there will be, or the first year, some immediately released Jupiter program, science, Jupiter and its rings and atmosphere and some of its, I think some of its moons as well. So that's something to look forward to. Most of the guaranteed time observations and the general observer observations, these are people who wrote into Space Telescope with their proposal and said, I want to do this science, and they were selected because it was great science. Most of that has a 1-year proprietary time, and that allows those astronomers the luxury of having a year to analyze their own data that they have proposed to do. And so that data, you'll have to wait for about a year to see it. But then after that year is over, it becomes publicly available in our archive, just as all Hubble data that we've taken over the past 30 years is available in a public archive for all astronomers to use. That's it. That's the Barbara A. Mikulski Archive for Space Telescopes, MAST.
Yeah.
where you can get Hubble data.
You can get Hubble, you can get Kepler data, you can get, I mean, it's for space telescopes. There's a bunch of missions that are supported here. Go ahead and get all of the data, raw data. Even
now,
go ahead.
Yeah, absolutely. I was just going to say that my program, which is solar system based, things in our solar system, with the exception of the Kuiper Belt object data, all of my data is going to have 0 proprietary time. So any planetary astronomer in the world will be able to get our data as soon as we get it in the archive. It'll be broadly shared. And I did that on purpose because I want everyone in my community to have the chance to work with this data so they can get ready to propose for the next cycle and the cycles to come. I can't do that with Kuiper Belt objects because that program is shared with all of the instrument teams.
Oh, okay.
We're sharing all of our data, and those instrument teams are going to be working so hard to get their instruments fully calibrated, fully ready for science, that they won't have a chance to do the instant science on it. And they requested that we keep the Kuiper Belt data proprietary for that full year.
Okay.
And of course, yes.
All right.
For that.
Give them that opportunity to get
right.
Okay, yeah. but after that, then you share it with me personally only, right? And then I get to use it for like a week.
Yeah, right? You wish. In your dreams.
So
ask a question. I just want to answer this one question because it's about me.
Please.
My science.
Yeah.
Why should we use our precious James Webb Space Telescope to look at stuff in the solar system? Haven't we sent spacecraft everywhere?
Ooh.
Why should you bother? It's like, okay, my friends, Uranus and Neptune, I don't know if you can see Neptune there, but you know what? We've only ever sent one spacecraft there, and it was launched in 1977 with technology from the 1960s. And we learned a lot from the Voyager 2 flybys of Uranus and Neptune, but we've never gone back. And what we have learned from our ground-based telescopes for those 2 planets, as an example, is that almost every aspect of those planets has changed. Their atmospheres have radically changed. Their ring systems have changed. Their moons change. And we have no insight at all into their magnetic fields or interiors from remote sensing from the Earth or from Hubble. And so with James Webb Space Telescope, there are questions that we can answer that I've been waiting. I personally have been waiting for 35 years to know the answers to about the upper atmospheres of these planets that we just cannot do because we don't have a spacecraft there. Similarly, there is science that you can do on comets, asteroids, Kuiper Belt objects, Jupiter, Saturn, studying lakes on Titan. We don't have a Cassini mission there anymore, right? Can we see the lakes on Titan and give some idea of its atmosphere before that little quadcopter goes and flies around, Dragonfly? Yes, we might be able to provide some insight. Can we study the plumes of material being ejected from the southern poles of Europa and Enceladus and look for signs of carbon-based matter in those water plumes? Yes, and that will help us understand whether or not life may have gotten a foothold in those icy oceans. So there's great solar system science to be done with Webb to complement our spacecraft missions. So that's my quick summary. And maybe it's time to do another giveaway, Christian.
I think it is. I was about to ask if you want to do another giveaway. I know we're a little bit past the bottom of the hour here. So now I thought I'd change it up. So let me bring up. This is also from Startorialist, by the way. Let me come over here to my browser. And I was thinking, since it's the holidays, we might be having a little bit of, might be having a beverage or so. What about these JWST pint glasses? Would anybody, like some of these? I think I'd like some of these actually.
I think I want one of those too.
Yeah, I think Heidi, we're gonna have to have a couple of these right after the show. But anyway, so Heidi, do you have a question in mind?
Oh, geez. I was so busy checking.
I know.
I wasn't thinking of questions.
Okay. Let's see. All right. Now, this is maybe not fair, but this is something that we're going to talk about pretty soon, and I know that a few of you have already been following the James Webb mission. So, okay, so too loud. I apologize. Hopefully, hopefully I'm I'll try to bring my audio down a little bit here. Hopefully, that's a little bit better. But this is for the beer. Okay. We might have to do another one of these. Here we go. What are James Webb's mirrors made of? And I want to be really clear. What are the mirrors themselves? Not what are they coated with. What are the mirrors made of? Okay. I think I just saw the first one come through. This one comes from Gringo Slick. Beryllium, congratulations. That is absolutely correct. These mirrors are in fact coated in gold, but they are made from beryllium. Now, why in the world would we make a mirror out of beryllium, Heidi? First of all, before I do that, Gringo, would you kindly go to my About page on my YouTube channel and click on the email address and then send me your mailing information, and I'll order these up and get those shipped out to you. By the way, friends, if I may also just mention one other thing. If you'd like to get any of this wonderful stuff for yourself, because I won't be able to do enough giveaways for everybody today, but if you'd like to get this or anything else, Startorialists are offering a really very, very generous, let me see if I can find it, yeah. There's actually two vendors, but this is from Startorialist, and what they've done is they're giving I want to put this up here, so that you can see this, but little text overlay here. Okay, they're doing LPA 10 for 10% off. So it's LPA 10 for 10% off. Let's see if I can show you that here so that you can see it. Hopefully I've got that somewhere here on my screen. Let's see, where is it? Here it is. Yes. Okay. So if you use LPA 10 from Startorialist, you will get 10% off of everything that is being made available today. And there's a second website I'd like to introduce you guys to. It's called sciencesocks.co, and well, Daniel's taking a very well-deserved break, but Daniel has very kindly also offered a discount of, let's see, he did a discount, and I believe it's also 10% off if you use the promo code LAUNCHPAD. That was something that Daniel over at Science Socks did for us, which is very nice and very generous. So please make sure you check out sciencesocks.co. and make sure you check out startorialist.com for those generous offers. So I want to thank them. By the way, this is not they're not sponsoring me. This is just a shout out to them because they just do such great work, and I just love their work. All right, so we got our third giveaway today. Yeah, we're definitely gonna have to do another giveaway at the top of the hour. I just letting you know. So start thinking of that question.
Okay, so let's talk about beryllium. Some people have already addressed this in the fast-moving chat there. So if,
I know, which is on slow mode.
So the reason the beryllium was selected is, first of all, it's extremely light. It's very lightweight. And we're launching this thing into space, and the lighter the telescope, the less rocket fuel you need. And also, once it's in orbit, because if it's lightweight, the less fuel you need to move it around to do your station keeping. So the lightness, that was one thing. The second of all is it's a very strong material. When you have formed it into these mirror hexagonal shapes, it's very strong, keeps its shape. And thirdly, and this is perhaps the most important for the space telescope, it's a very thermally stable material, all right? So that when there's difference in temperature changes, that shape doesn't change very much. And we can characterize very clearly how much it is going to change with time. These mirrors, as we were making them, we were thermally testing them. We would polish them and then put them into a very large chamber at Goddard Space Flight Center. And then also we had the one in Houston, and we would test them in the cold and a vacuum of space in these space chambers. And then we would test their shapes and then bring them back up to room temperature, check their shapes. So their thermal shape is their shape as a function of temperature is very, very well understood. There are other materials that are good for mirrors, so different kinds of glass, for example, but those are not as strong, they're not as light, and they're not as thermally stable as the beryllium. And so that's why we made these mirrors out of beryllium. And why, you may ask, are they coated in gold? And that is, in fact, gold, like the gold in my MIT ring here. This gold is, we didn't choose it because it's expensive, not why. We chose it because gold is a very effective reflector of thermal infrared light. And that type of light is exactly what this telescope is being designed for. And so that was why we chose gold for the coating of this mirror. Our other ground-based telescopes, and Hubble, for example, are not designed to be optimized for infrared light. And that is why they're not gold. They have different kinds of coatings they use on telescope mirrors depending on what wavelength of light that they are trying to reflect. And so that is why these beryllium mirrors are coated in gold.
Okay, now I'm also seeing some comments from the chat, and let me bring up our browser over here. We'll take another look. People are saying there was a sudden jump in hot side temperatures. I think we can see that there is starting to become a little bit more of a difference between the hot side and the cold side. That certainly is indicative that okay, the shield is out. And I'm also seeing some comments, and let's take this with a grain of salt, okay, folks. But I'm seeing some comments that the Sunshield is already jammed or they're having a problem. We have no verification of that at all. There's absolutely nothing. I'm not saying it's not. There could be a problem, but nothing is trending on Twitter. I think we're just sort of being maybe teased a little bit here by some folks. Let's not stress about this, guys. Give them a chance to work. Let's get this thing deployed. Anyway,
we started at the top of the hour saying that
yeah,
these deployments take a long time. The videos you see are highly sped up. They take hours and hours to deploy. And so we warned you at the beginning that we may not see a deployment during the time of this broadcast. So I think that's bearing out, since I think we may be needing to stop when we get to the top of the hour.
I think so.
But yeah, sorry that we couldn't bring you an actual deployment, but follow Christian and NASA and me on Twitter. As soon as we hear that there's been a deployment successfully completed, we will be sure to post about that.
Oh, you know it. As a matter of fact, and I'm just flopping around here trying to find our two-shot here, but since I can't seem to get that right, if we go to, let me just go back to this. Let me go back to this screen right here. This is just NASA's live feed, so disregard that. But anyway, yeah, there's going to be a lot of information coming out, and we're still waiting on this. I'm not too worried. I doubt that we're snagged. We'll just have to see, guys. We'll just have to wait. Patience comes to us. Yeah, so Galaxia is asking, why is telemetry not shared? Well, we did talk about that before, but in case you're just joining us, or in case I'm way behind on the chats, yeah, it's just because it has to be analyzed and interpreted, and people are going to I don't know why they don't do it, to be honest. I think it's just because of security purposes, quite frankly. If you share the data out, people might find a way to work their way in. I mean, this stuff has to be encrypted. It has to be protected. So, yeah, I think so. Yeah, who would ever lie on the internet? Yeah, exactly. So how about the comment that you call, I was first at it as well. So Brian, when we get these responses into our giveaway questions, we're trying to do it as fairly as we can. But there is one thing, and I'm going to repeat this for those of you who didn't catch me the first time. When we do these things, you type in your response to a question, you see your answer come up, and maybe you see your answer come up first. The problem is that you're seeing your answer come up first because that's what your browser is showing you. That's what your local network is showing you. That's what the local content delivery network is showing you. We can only go by what we see, and Heidi and I can only see these things coming in and in the order which Google feeds them to us. So we just have to pick that. We're effectively picking an answer at random, but we're trying to pick somebody who got the answer early on, which implies that they knew about it versus Googled it up and, hey, what are you going to do, right? We try to be as fair and equitable as possible. Okay. Now, there was another question about, and Heidi, since you are indeed the queen of the outer planets, at the risk of jumping around a little bit here, as I've said before, what about looking at Neptune's moon Triton? What would it help to reveal? Or how can it be an ex situ complement to an in situ orbiter like a Neptune Odyssey? Ooh. Heidi, what do you think?
Yeah, Triton's on the list. Triton's on the list because we will be able to measure chemistry on the surface of Triton using James Webb Space Telescope. And those of you who are not familiar with Triton, you may not know it's an active moon. When Voyager flew by in 1989, it saw cryovolcanoes actively erupting in the atmosphere and creating a thin veneer of atmosphere around Triton and changing the surface brightness. You could see places where there was dark splotches from these active cryovolcanoes. And we haven't been back to Triton since Voyager flew by in 1989, but we have measured Triton as it has crossed in front of stars. And by watching the starlight very carefully as it is blocked out, we can measure the atmosphere of Triton and figure out its pressure, its temperature, its molecular composition. And what we know from those occultations is that Triton's temperature has gone up slightly and its atmosphere has changed in ways that are a little interesting and puzzling. Now, we weren't totally surprised by that. My colleague Candy Hansen has done some modeling of Triton over many, many hundreds of years, and she predicted that the temperature of the atmosphere would change and that it would condense out and then puff up again and condense out. Pluto's atmosphere does this as well, just so you know. And so, but what Triton is like right now, today, that is something that James Webb Space Telescope will give us some insight into. It will not resolve the moon. We won't be able to see the surface, but we will be able to measure the integrated reflected light and figure out the chemistry of the surface facing us. And as this moon rotates, we can try to map out the chemistry as a function of time. That will be really useful as we start to plan for, hopefully someday, future missions back out to the ice giant systems. In the meantime, it's the data that we've got.
So. Absolutely. Okay.
We'll get
right. So this brings up another question about almost like the complete, I don't want to say opposite of it, but Fernandez asked, and this was way back early on, so apologies for taking so long to get to it. And thank you so much for the £2 super chat. So much. Thank you for that. And thank you for all of you for these super chats. Guys, this is so generous of you. Anyway, do we have a theory of the earliest galaxies? Heidi, I know that's a little bit outside of your bailiwick, but what's your best understanding of how galaxies are put together?
Yeah, well, this is one of the things we're really interested in seeing with James Webb Space Telescope. Yeah. With the Hubble Space Telescope, we have done a series of different observations of different deep fields where, we stare at a piece of sky with the Hubble Space Telescope for days at a time. And that allows us to sense very, very faint, distant galaxies. And what we have seen, we can also figure out the distances to these galaxies by looking at their colors and looking at how light is absorbed at certain wavelengths of light, what certain colors are there or not there. We can use that information to get their distance. And what we find is that while the galaxies in our neighborhood, like Andromeda and the Sombrero Galaxy and many other large galaxy pictures you may be familiar with, are very, very interesting and spirals and, just kind of normally shaped, when we go more distant, these galaxies tend to become clumpier and sort of chunkier and blockier and not quite as uniform and spiral and normal shaped. And so by using James Webb Space Telescope to be able to see the very first galaxies, these will give us insight into the process by which these very primitive, almost proto-galaxies were forming out of the first stars and the first material there in the universe. And it's sort of like how would I put this? The James Webb will allow us to get baby pictures of galaxies, whereas with Hubble, even with our deepest fields, we've only been able to go back to the high school yearbook pictures. So,
right, with the really with the mullet haircut and everything. Yeah, yeah, that was me.
You don't know what I looked like in high school, right?
Oh.
But baby pictures, they tell us how this formation process truly comes to be. We have a lot of theory. Many theories, and we have many models of how this takes place. And what Webb will do will give us data that will actually allow us to determine which of these theories and models are actually the correct story of early galaxy formation by showing us what those early galaxies truly looked like.
There's a beautifully said. I mean, and this also brings up another question that that I have seen come up several times, and I'm just going to try to find one of them to post up here. But will there be a Webb deep field?
Oh yeah.
Yes. Yeah. Yeah.
Yeah, definitely.
But what is the deep field anyway? Like, what's so great about that?
Well, the original Hubble Deep Field was a little piece of sky. Sort of imagine a soda straw that's looking through a soda straw at a piece of sky just close to the vicinity of the Big Dipper.
Tiny little, okay, yeah.
That's how big the Hubble field of view was originally. Yikes. Back in the early days. So soda straw, Big Dipper, and they picked a very blank part of the sky. Like they tried to find a piece of the sky where they couldn't see any stars, right? And then Hubble stared at that piece of sky for over 10 days, integrated observing time. Not all at once, right? But it added up and added up and added up to the equivalent of like 10 days worth. And what they found is in that little tiny piece of sky, there were thousands upon thousands of galaxies in just that piece of sky. That was the Hubble Deep Field. And we've since gone on and probed even deeper into what we call like an ultra deep field. And I see you've got it on the screen there. Every one of those splotches that you see there, I think three of them might be stars, but all the rest are galaxies, collections of billions of stars. And some of them are reddish and some are yellowish, some are bluish. And by looking at the light from these stars very, very carefully, from these galaxies, we can determine their distances. And we are able to see the distance and the colors change with time. We see the structures change. I think there's one star. You see that one thing?
Yeah, that's your star.
That's your star. But all those other things are galaxies made of billions of stars.
Yeah.
As I said, we've since gone on to do ultra deep fields, and other telescopes have also stared at these fields as well. And by looking at these fields at different wavelengths of light, we are able to build up a story about the history of our universe. That's why the Hubble Deep Fields are so important. And we will be looking at the Hubble Deep Fields. And there are many other fields in astronomy that, people who are astronomers are like, are you going to look at the Goods field? Yes, we will look at the Goods field. Are you going to look at this field and that field? Yes, people are proposing to look at these other fields. So, we work our telescopes together with one another. There's, so much we will learn just from Webb, but Webb in conjunction with Hubble, in conjunction with the Keck telescope, in conjunction with the Chandra X-ray Space Telescope. This is how we truly study the universe. It isn't just a one thing. This is exciting for us because this is opening a new infrared window. We've had infrared telescopes in the past,
right,
but they've been very small telescopes, right? This is a much larger telescope, so we can see much deeper into the universe than we ever could before with this telescope at infrared wavelengths. So that's why we're so excited about James Webb. But James Webb with Hubble, with Chandra, with all of our ground-based telescopes. That's how we will be really making the true advances of the coming decade. That's why we're so excited.
So there's going to be some nice Webb deep fields, and we're going to be seeing a lot of suddenly these very, very faint poofs of light are going to suddenly burst bright, and we're going to see their infrared. It's important to remember, though, that with the universe expanding, you've got redshift, and Heidi, forgive me if I just repeat something that you've just said, but part of the reason we can't see any deeper is because most of the light from those galaxies have been shifted into the infrared part of the spectrum. They're gone. They're out of the visible window. Even if Hubble were twice the size, it would eventually not be able to see anything because it's mostly infrared light at that point. So this is where Webb comes in. This is why Webb gets called the successor to Hubble, I guess, because it is scientifically picking up where Hubble leaves off, at least if this is your science. But yeah, we've got a huge window that's opening up ever so slowly in space, but opening up. So we did just get confirmation that the great legendary Betty White has passed away at 99 years old today. Thank you, Betty. We love you. Yeah. The thing that I would like to ask about, and oh yeah, well, you know what? I think we have to do another giveaway. We are indeed at the type of the. Okay, I speak. I speak.
Top of the hour.
I speak. Yeah, I speaks English good, and my let's see. So we did a couple of these, right? We did a couple of these ornaments here. But I mean, nothing says Christmas better, I think, than a good pair of socks. Now this appears to be sold out right now, so this would take a little ways to get there. But I know that as a middle-aged man, I crave socks on Christmas, and I'm sure everybody does. So I'd like to go ahead and pledge to order a pair of these socks for the next person who can get this question right. Heidi, do you have a question? I know. I'm putting on the spot. She's like, I'm going to kill you, Christian. What did I just...
If you had warned me that I would have to be coming up with questions.
I didn't know. I mean, I could probably come up with a question as well, I mean, unless we want our audience to suggest it. Well, I guess that would kind of defeat the purpose, wouldn't it? Yeah, so I think Okay. This is for two pairs of socks. Like one pair for one winner, one pair for another winner. Why not? Earlier, Heidi asked what is the primary science reason why Webb was built. But there's two other major science questions. Well, three other science questions that Webb is going to be used for, whether it was, quote, designed to be used for or not. But there are four major science questions, right? The earliest galaxies, how and the first stars to form the universe. But there's three others, all of which we've talked about throughout the course of our conversation. The first three responses will win a pair of socks, of James Webb socks. Let's see what we've got. What were those three things? So we already talked about early galaxy formation. Okay, we certainly talked about that. But there's something else that comes up here. All right, I'm going to try to flag what I think are the correct responses. Okay, here we go. Okay. All right. Pavel Hudrik, atmospheres of exoplanets. Ding, ding, ding. Absolutely, that is one of them. Please email me and send me your contact information. So that was the first one. And again, that's the first one that we saw on our chat. It may not be you may have said that and you may have seen yours come up even first. It's just the way it works, right? So we already did talk about early galaxy formation. So no, that's not one of them. So we have first one. What else is another one? I'm looking for it. Can anybody see? Okay. I think we're going to give this one to Nicholas Pinnerin because Nicholas said birth of stars. Births of stars, absolutely. Being able to penetrate and pull back the veil and see those stars forming. Okay, what was the third one, Heidi? Let's see. I think, well, what do you think, Heidi? Is this going to be is this acceptable? It's the first one that I saw, or should we be more specific? Judges?
I think you can give it to him. It's really not just imaging, though, people. Spectroscopy.
Yep.
Breaking the light out into its rainbow of colors.
Yeah,
And
so
looking for the characteristic molecules absorbing or emitting light. Spectroscopy, it's imaging and spectroscopy within our solar system.
so Constantine picked up on that, hinted at with the CO2. So Edward and Constantine, you too are each getting a pair of JWST socks. Why not? Please send.
I have those socks, by the way, and they're really nice. They're soft and they're warm and comfortable. So
We are going to have to do one more giveaway because because there's one thing that I get asked more than anything else, and that is, where do you get this pin? And this pin, I actually picked it up on a website called officialnasagear.com, but they are out of stock of those. So Heidi, you got to find out. You got to decide what this question is going to be.
Ooh, okay. All right. Okay. Well.
And while Heidi's thinking about that, and then we're going to come back to your questions, and then we'll probably start to wrap things up. But let's go. Right. Let me show the. Oh, actually, you know what I'll do? I think Startorialist.
Ready.
Okay, ready. Good. All right. Startorialist actually has a really, really nice pin, and honestly, I think it's really sharp. So I'm going to go ahead and offer to do that one. And remember, folks, you've got those coupon codes, but I know that they had a pin here somewhere. Okay, well, look, it's going to be a pin. It's going to be like this, or maybe even nicer if I could find it, and I'll get it from one of these two shops. But Heidi, go ahead with your question.
So this mission is being led by NASA, but there are two other space agencies that have played absolutely crucial roles for the James Webb Space Telescope. What are those space agencies? Two of them.
Two of them. Okay.
Okay, I see it. HLIXIR, HLIXIR, CSA, ESA, Canadian Space Agency, and the European Space Agency.
That's how we do it. That's fantastic. Sorry, HLIXIR, please send me your email address, and we'll send out that pin from whichever vendor we get it from. We'll send that out to you. Oh, great.
So let me talk for a moment about their contributions.
Yeah, please.
People have recognized that this is a strong international partnership between NASA, European Space Agency, and the Canadian Space Agency. NASA has been the lead on developing the telescope itself. The instruments, however, we have a European instrument, an instrument that's fully European in design. That's our NIRSpec, our near infrared spectrometer, which has fabulous microshutter arrays. That's being fully developed by the European Space Agency. Many industry partners in Europe have contributed to that. Also, our NIRCam, near infrared camera, called NIRCam, has a joint European lead. The Gillian Wright is from Edinburgh in Scotland, and so there's a strong contingency there. If you were watching the launch, you know that we launched on a European rocket provided by Arianespace. And so the rocket came from the European Space Agency. And so very strong European representation in the James Webb Space Telescope project. Canada, its primary, most important from a science perspective contribution is the fine guidance sensors and in the nearest instrument, that is what we use to point the telescope and do the tracking of the stars and the planets. And so the fine guidance sensors are from the Canadian Space Agency. So this is a partnership that's been 20 years in the making. And so I just want to make sure that you all appreciate the international aspect of this mission. It isn't just NASA, it is all of us working together. And so I'm very, very pleased to support my European and Canadian colleagues.
Absolutely. This is like I said, this is humanity at its best. It's coming together, getting, doing stuff that is worthy of a civilization. And I don't mean that in any hyperbolic way. I mean, it really is. This is what we should be doing. This is what we should be. No, we're not solving world hunger here. I get that. But if I may quote the legendary philosopher Hank Green, who said that the role of government is to do two things. It's to decrease the suck and increase the awesome, right? So we got to make our lives a little bit better. Yeah, we need to do things about hunger. We need to do things about access to healthcare, voting, things like that. But then that's decreasing the suck, right? And then you got to do these things that make living in a civilization like ours worth living in. And that is these awesome projects like Webb. So that's so cool.
And honestly, it's not an either or.
Yeah.
The money, it's not, they don't, you don't, if you stop doing one thing, you aren't going to necessarily do the other thing.
Mm-hmm.
So it's really both. We need to do both as a civilization, in my opinion.
I completely agree. Agree. So let's take a look now. Let's see where we're at. So we're still here at this stage in our, on the NASA website. And again, it's definitely gotten a lot. It seems to have gotten a bit colder on the on the cold side. So that to me, that's kind of like a clue that this thing is opening up. Now, whether or not we've got so we have our temperature data available right here, just kind of showing you the temperature differential. But the fact that we're seeing this rapid cool down, or not rapid, but we're seeing a significant cool down. Believe it or not, though, what you do see here on this web page is absolutely nothing compared to the cool down that we're going to see once the Sunshield is fully tensioned. And we're talking like the end of the weekend. Okay, so today, under best case scenarios, even if Heidi and I stuck around here for another 5 or 6 hours, which we're not going to do, but even if we did, the best we would hear is that, okay, the mid-boom's deployed, right? And the shield is basically at that point would be in this configuration right here. Let me bring it back to this. Yeah, okay, so this would be like the configuration that we're kind of hoping to see by the end of the day. Once I can freeze frame it there, and I'll bring up the animation. So this is our best hope for a situation. Actually, the Sunshield would even be flatter than what you see here. The way this frame starts when the layer separation has started. So this is what we're hoping to see later this afternoon, maybe early evening. And why aren't they just going to go ahead and proceed to unfurl the layers? Well, a couple of reasons. One, people have to sleep. Let's face it, these are human beings at work here. And number two, again, analyze the telemetry. Make sure that what we think the telemetry is telling us, make sure we understand what the telemetry is really telling us, right? And create a truly accurate model. And then when everything's good to go, it will take time for those layers to separate. As we've said a few times today, this is all just sped up just for our convenience, so we're not watching like a 72-hour long animation. This is just to give us an idea. Once the Sunshield is deployed, what is the percentage chance that the rest will deploy successfully? I'd say about as good as they are before it deploys. In other words, every deployment is its own challenge. Every deployment is its own milestone. But here's the good news. We've retired a lot of risk already, right? We never have to go through launch again. We never have to go through separation again. We never have to worry about getting power from our solar arrays, right? So yeah, a lot of risk is retired. So this is kind of where we're at, friends. This is what we're waiting to see what happens. But Heidi, are there any? Let's see. Are there any closing thoughts or any as we kind of start to wind down here? We're gonna wrap this up toward the bottom of the hour. But Heidi, do you have any closing thoughts on this? Well,
I just wanted to thank all the listeners. I wish we could have brought you a deployment in real time. We can't so far, at least unless it happens in the next 15 is announced in the next 15 minutes. I we might get an update. I just got a message that we might get an update in the hour, but I'm not sure if I believe that message. So we'll have to wait and see. Um,
Maybe I'll stick around. I don't know. We'll see.
yeah, we'll see. I do want to thank Christian for providing the opportunity to answer some of the questions. I apologize that we have not been able to get to all the questions because there have been a lot of great questions going by. And so, perhaps Christian and I can try to set something up in the future and maybe get to some more of these questions.
I was going to say maybe, I don't want to put you on the spot, Heidi, but probably in the next week or something like that, because then we'll have then we'll know about our Sunshield situation, and maybe we could do something. But we'll touch base. We will definitely have you back because there's so much more to learn and so much more to talk about, so much more to get excited about. Oh my gosh. Yeah.
I think, following on Twitter is the best way to stay up to date because NASA is doing a great job. As soon as it knows it's got a confirmation, it will post on Twitter and other social media outlets and its website, the blogs.nasa.gov/web. So you can find out there. And I just continue to be really excited about this telescope and nervous.
Yeah.
Still nervous.
Focused is the word I'll use because you know me, Heidi. I'm a steely-eyed missile man. All right, never mind. I'm not. I freak out. Let's do a little bit of an update here. Do we have anything? Nah, I don't think so. All right, but anyway, yeah, you can definitely check out more more on this on blogs.nasa.gov/web. Remember, if you are visiting if you're visiting Sartorialist and you would like to get, and this is today only, by the way, but if you would like to get, this is Sartorialist. If you'd like to go to their website and buy some JWST swag, use the promo code LPA10. Oh yeah, I just remembered. I need to do one more giveaway. Yeah, we should do one more giveaway because I did promise a Launchpad astronomy thing, right? Okay. Heidi, can you think of a question?
Oh, I did the last question.
I know. I felt bad. I realized I promised a Launchpad astronomy giveaway, and I tell you what. If I can. Okay, I think I've got it. I think I got a question coming my way. We'll do one more giveaway. Sorry, folks. This is all. Okay. What is this thing? Okay. What does this thing do?
We don't see it yet.
I know you don't see this. But let me tell you what this will be. So I'm going to. All right. I got to set this up here. Okay. Let me bring this up here. Hide this so we can see everything here. Get this all set up for you. Okay. I'm going to show you this. Because if you go to teespring.com/stores/ Okay. This is going to be for a Launchpad Astronomy T-shirt. I'll show this to you here. Here we are. So it'll be this T-shirt right here. This is going to be done up in the tri-blend style, so it's really nice and cozy and comfy. But I'll be sending one of these out to whoever can answer this question. What is this thing called? This big rectangular thing called hanging off the back of the telescope. What do we call it? Tells time. No, it doesn't tell time. We have a name for it. What do we call it? Oh, not so quick this time. Wow.
Oh.
I chose a real. Oh. Okay, starting to come in. Okay. It's the shovel. No, it's not the shovel. It's not the shovel. Sorry. And there's two names that I'm going to accept So, but I think I did.
I see it. JS Sherrod had it.
Okay, let me find JS Sherrod. Aft momentum flap. Yes, that is it. JS Sherrod, aft momentum flap. This is what helps to stabilize the spacecraft's momentum as sunlight pressure strikes at one side of the solar shield. This will help to keep the spacecraft stabilized and reduce fuel consumption. That's it. Yay, congratulations. So, once I can't even get my applause to fire. Huh, that's cool. Anyway, yeah, my applause isn't working. All right, so I really hope I want to thank all of you for watching, and I really hope my wife hasn't been watching because she's going to wonder why I'm spending all this money, but you guys have been so great, and I really want to thank all of you for coming on today, and I know I didn't even get to the super chats, and I feel so bad about that, guys, but so many of you were so kind and so generous with your, not just with your time, but also with your money with the super chats today, and I just got to thank you for all of that. And I know we didn't get a chance to talk about those, but I'll tell you what, I'll gather these up and we'll start off with these the next time. How's that sound, right? And just as thank you, Cheryl Wolf, appreciate it. Thank you very much, everybody. Hiroshi loves you. We love you too, man. This has been a lot of fun, and I'm so thankful to all of you. And I wish everybody here a very happy and safe New Year's. Heidi, final thoughts?
Same for me. Happy New Year to all. Just keep watching, and I think Christian and I will try to do this again sometime to maybe get some of these other questions.
All right. Thank you all so much, and until everybody have a very happy and safe New Year. And I'll go ahead and want to say big thanks to Heidi Hammel for joining us. And as always, my friends, please have a happy New Year and stay curious. Good night, everybody.